Hi friends, today's my topic is 2 wattmeter method. First question which I have taken is, in a 2 wattmeter method, if the readings of the 2 wattmeters are 500 watt and 500 watt respectively, the load power factor in a balanced 3-phase 3-wire circuit is. This is question from SSC JE 2019. Option A 0.8, option B 0, option C 1, option D 0.3. So for this type of question, I have one table. There is a shortcut method table. This is so for 2 wattmeter method where we know the wattmeter readings W1 W2 like that. W1 is equals to W2, wattmeter 1 reading is equal to wattmeter reading 2. Then what will be the phase angle, what will be the power factor, and W1 is equal to 2 W2. Then what will be the phase angle, power factor. Here you can see when W1 is equals to W2, phase angle is 0 degree, pi is 0, and power factor is unity. So in this question you can see wattmeter reading 1, W1 is equals to W2, that is nothing but W1 is equals to W2. Then what is the phase angle and what is the power factor? So phase angle is 0 and power factor is unity. In this question what they have asked, load power factor in a balanced 3 phase. So from this table only we can tell the answer like this. Option C is right answer. So you have to remember this table when W1 equals to 2W2. Like this type I have taken some more questions. Second question is, in the 2 wattmeters method of 3-phase power measurement of a balanced load, if the reading of 1 meter is minus 200 watts, then power factor of the load is. So 1 wattmeter reading is minus 200. Just they have given 1 wattmeter reading W. Can take it as W2 is negative. So W2 is negative. So from this table, so you can observe this when W1 is equals to minus W2. So 1 wattmeter 2 reading is minus. So then angle is 90 degree, power factor is 0. But in this question you can observe W1 about wattmeter 1 reading, they have not given any readings or hint. So by here see the options: A greater than 0.5, B less than 0.5, C equals to 0.5, and D equals to 0. So these two conditions are we can neglect. So by observing options only, in these two only. So W2 is negative, but they have not given that W1 is 0 or W1 is they have not given W1 is 0 or like anything they have not given. So by observing options and questions we can tell W1 is not equals to W2 in negative way, and also W1 is not equals to 0, like that they have not given anything. So by observing option we can tell that it is not equals to W1 and it is not equals to 0. So it is not 0.5 or it is not 0 power factor. We can say like this: the power factor of this system is greater than or equals to 0 but less than 0.5. So option B is right answer. So only thing they have given is negative reading. So in these two option only we can select it is not equals to W1 and it is not equals to 0. So if it is equals to W1 means we can select 0. If they have given like that W1 is equals to 0 means we can select 0.5. So they have not mentioned anything about W1. So we can easily say that power factor will be maybe equal or greater than 0, but it is less than 0.5. So they have not given equal to 0 or greater than 0 like that. They have not given. Only they have given is less than 0.5. So we are selecting the option B, less than 0.5. So third question is, a 3-phase balanced load which has a power factor of 0.707 is connected to a balanced supply. The power consumed by a load is 5 kilowatt. The power is measured by the 2 wattmeter method. The reading of the 2 wattmeters are. So in this question what they have given, power factor. So 0.707 power factor they have given, and what they have asked, 2 wattmeters reading. This is question from GATE Gate 2015 from question paper. Option what they have given: A 3.94 kilowatt and 1.06 kilowatt, 2.50 kilowatt and 2.50 kilowatt. Here W1 is equals to W2. So here W1 something value and W2 is equals to 0. So and here also W1 is nearly equals to W2. Small difference 0.4 and 0.96. 2 in the range of 2 only they are. So here we can see W1 is W1 3.94 kilowatt, W2 it is greater than means 2. We can just assuming W2 means is double this 1 point. Just we are assuming. Why we are assuming like this means in the table you observe when W1 is equals to 2W2, what is the power factor? 0.8666. So in the question what they have given 0.707. In the table you observe power factor is very nearer to this 7 point, very nearer to this. So condition will be like this only, 2 wattmeters. So by observing option, it is not equal, it is not 1 wattmeter 0, it is not possible, it is not possible. So it is also not possible. So only it is nearer. It is matching to this condition. This condition. Nearer. So wattmeter readings also matching. The option A is correct. So only thing is you have to remember this table. You have to relate the readings. If the wattmeter 1 reading they have given something double, wattmeter 1 is 5, wattmeter 2 reading is 10, like that, then what will be the power factor, phase angle they may ask. So you have to relate the wattmeter readings, phase angle and power factor in. If they ask in between, they'll also like this 0.707, no? Like that only. If they ask, you can answer. So thank you friends. Please like and subscribe my channel and support.